Okay, so today what we're going to do is we're going to look at solving linear equations. So the first thing we want to do is define what makes something an equation. And it's really easy. Anything is an equation if it has an equal symbol. You can call it an equal sign if you want to, but it's actually a mathematical symbol. It doesn't make that much difference. But anything is an equation if it has an equal symbol. But there are lots of different types of equations, the most basic of which is the linear equation. So we need to talk about how we know that something is a linear equation before we can solve it. And the way to tell is because it has no exponents or special symbols. It's just a collection of terms. You have variable terms, number terms, and the equal symbol, and different operation symbols. But no special symbols like square roots or anything like that. Okay? All right. Once you've identified something as a linear equation, then we'll talk about the steps for solving it. But before we start that, let's talk a little bit about what your whole point is. The goal of any solving any linear equation is to get the variable completely by itself. Now, completely by itself means that the variable, which again, remember a variable simply means a letter, so you have A, B, X, Y, whatever letter you're using in your particular equation. It's not by itself unless there is nothing else with it. So if you have 3A, that's not finished. Negative Y, it's not finished. The X or Y or A or B, whatever letter you have, has to be completely by itself in order for it to be solved. And the method that you're going to use is simply the opposite operation. All you need to do is look and see how two things are connected, and you take them apart by doing the opposite. So what's the opposite of division? Multiplication. Good. Opposite of multiplication? Divide. Good. Opposite of addition? And subtraction? Just addition, right? So those four operations, all you're going to do is just find the opposite operation of how the things are connected, and you'll do the opposite. Okay? Now, an important point is that you can do anything to an equation as long as you do it equally. So in other words, you could divide by 4 as long as you divide everything by 4. You could add a 6 to one side as long as you add a 6 to the other. You could multiply by negative 23 as long as you multiply that times every single term. So you could literally do anything you need to an equation as long as you do it to every term. A linear equation. And the first steps are going to be simply to clean up the equation. Before we can solve an equation, we need to get rid of anything that we don't need. Make it as simple as possible. And the first thing that we're always going to deal with are brackets. If you have brackets in your equation, then you want to get rid of the brackets first. And you may or may not remember, there are 3 steps for getting rid of a bracket. First, you would do any math that you have inside the brackets. Second, you would look to see if there's an exponent on the bracket, which is going to be pretty rare because I just got through telling you that there aren't any exponents in a linear equation. But there could be originally, but then they could subtract away. And then finally, you'll look for a coefficient. You may or may not be used to that word. Coefficient simply means a multiplier. So for example, here's an example of a bracket. Clearly the x plus 4 is the inside, the 2 is the exponent, and the 3 is the multiplier or the coefficient. And you can tell that it's a multiplier because it's right up against the bracket with no operation symbol in between. Multiplication is the only operation that requires no symbol. So if you see no symbol at all, no mathematical symbol, then you automatically can conclude that you're dealing with multiplication. Right? After you get rid of any brackets, the next thing you're going to do is you're going to clear the fractions. Now, most people don't like working with fractions, so that's good news with an equation because you can eliminate them. You don't have to work with fractions. But to eliminate them, we have to remember what they are. Does anybody remember what the fraction bar actually means? Divide, exactly. It's a division symbol. And so we're going to get rid of them by doing the opposite. So what's the opposite of divide? Multiply. So we're simply going to multiply every term by the least common denominator. Now, generally, you're only going to have one fraction in these equations that we're looking at right now, and so there will only be one denominator. So whatever that denominator is, that's what you'll multiply by. But if you had more than one, then you need to find the least common denominator, which means the smallest thing that they will both divide into. Say, for example, you had 3 and 4. What's the smallest number that 3 and 4 will both divide evenly into? Anybody? 12, maybe? Yeah, 12? Okay. So they have to divide evenly into it, though. All right. So we'll look at some examples of clearing fractions. The third step in cleaning up the equation is to combine any like terms that are on the same side. So on the same side of the equal symbol. Anything that you can combine that are on the same side, you'll combine those before you work to solve the equation. You want to move as few terms as possible, and so the most cleaning up you can do, the better. Now, there are times when you could work with some of these things. You might not want to clear the fractions. You might not want to clear the brackets. You can do some other shortcuts. They exist. You don't always have to do them in this particular order, but if you do, you will always get the correct answer. If you start taking shortcuts and moving things around, that's perfect if you understand what's happening well enough. But if you don't, then this is the way to guarantee that you're going to get the correct answer, right? So, again, there are times when you'll see people take shortcuts. The book does it. It's fine, but just beware. All right. So those are the processes for cleaning up. We still are not ready to solve it, or now we're ready to solve it, but we haven't talked about the steps for solving it. Again, our goal is to get the variable completely by itself, and we're going to do that with the opposite operation. But remember, we're taking things apart. So what we're going to do is we're going to use the order of operations, but we're going to use it backwards. The order of operations tells you how to put things together. So if you do it backwards, that tells you how to take them apart. So the first step in solving is to get all variable terms on one side. Now, a variable term, remember that a variable simply means a letter. So a variable term is any term that has a letter in it. And notice that it just says on one side. It makes absolutely no difference which side you move them. We typically, though, move the smaller one. And the only reason you do that is because if you subtract a small number from a large number, you end up with a positive, right? as long as the large number was positive in the first place. So if you subtract a smaller number from a larger number, you're in better shape. You'll have fewer signs, and the fewer signs you have to work with, the fewer sign errors you're going to make. Right? Now, and the way you're going to do this is by adding or subtracting. Because remember that terms are separated from each other with pluses and minuses. So you're going to remove them with pluses or minus. And that all depends on the sign. If the term is negative, then to move a negative, you would add. If the term is positive, to move a positive, you would subtract. Okay? And again, it doesn't matter which side the variable terms go. Second step, there's only 3, is get all number terms on the other side. Now, this time it does matter which direction you're moving, because your variable terms, everything is about the variable. So your variable terms will tell the number terms what to do. So if your variable terms move to the right, then your number terms have to go to the left. You don't get a choice. So always move them to the other side, away from your variable terms. You're still going to accomplish this by adding and subtracting. Again, and what you do is going to depend on the sign. If they're positive, you'll subtract. If they're negative, you'll add. And the third and final step is to divide by the coefficient of the variable term. Now remember, coefficient simply means a multiplier. So if you have 3a, that literally means 3 times a, and the opposite of multiply by 3 is divide by 3. So whatever that number is. Now be careful. If it's negative, then you need to divide by a negative. The sign goes with the coefficient. So if you have negative 2x, for example, you would divide both sides by negative 2. Not add 2, because you can't take apart multiplication with addition. You have to divide, but divide by whatever the coefficient is, including its sign. So be careful, watch those signs. Which, of course, you can avoid if you could make the variable term positive in the first place. Which raises an interesting question, because remember I said you could do anything you want to. So if you don't like the signs, what can you do? Change them. But if you change one sign, what?
Change the other.
Oh yeah, change them all. Mm-hmm. So if you don't like the signs, if you don't want to work with negatives, then change it. But if you change one sign, you have to change them all. Okay? So what we're going to do is we're just going to go to the book and look at a few examples of these. We're going to work some together.